Hello everybody and welcome to a chat from the engineering desk. I hope you're all doing very well today on this lovely Sunday. I have decided to cut down a bit on the short format videos, the shorts, and concentrate on the longer format videos again. The shorts actually don't bring that much value to the channel, so I'm going to have more of these longer videos as quality content from now and again, methinks. Anyhow, what I have here today is this power probe that I hooked up to a battery bank, and there you can see the display like so. So I'll power it up. On it is. And if I take a 9-volt battery, there's the reading, like so. So let's take it apart and see what I've done. Sorry about that. I'll show you how I built it. I'll take that away. And the battery. Let's start with this part. Like so. This is obviously just the housing. And over here there's a screen which is inside a 3D printed sleeve which is tapered and fits inside the tapered housing over here, the clear part, and then soldered onto the end. I soldered the spring which used to hold the light bulb onto the probe wire after cutting the spring off. And then you got you got 5 wires coming up here. Got your supply, I2C lines, clock and data, and then the probe wire, the sense wire. That just screws together like that. Then I just fed the wires up some of this braided nylon sleeving, which is quite neat. So I set that aside. This is also, it had a light bulb inside it, actually an LED inside it. I took that out, I took the LED out and I put a piece of wire where the LED used to be. It looks like a fuse inside there. Actually an LED. And then I soldered the wire on and I put this a cap over this where I soldered onto it, made it neat, made it pretty. Because you like our things to look nice. So that's the negative probe. And then I took an Arduino Nano and I hid it in here. So let me whip that open for you and we'll get into it. These are M3 screws. What I did is I 3D printed this little enclosure. It just houses the Nano, and in the end is the mini USB connection to it. Right, so the lid I 3D printed with some hex recesses for the nuts. So the nuts fit in there like that, and they're captive and flush. All nice and pretty. The Nano lives in there like that. Stuffed in there. So inside of there one can see the potential divider over there. What you can't see is the pull-ups on the I2C line because they're hidden in there underneath the screen. So we'll have a look at the drawing in a moment. So that's the Nano inside there. I'll put a bit of sleeving around the one resistor, and there's a 100k, and there's a 10k down to 0 volts. And to analog 0, there's your connection over there. Let's have a look at the drawing. So turn the camera off. There's the drawing. So there's our screen. That's a 128 by 64, but what we have in our probe is actually 128 by 32. But it works the same, it's just narrower, different shape. There's our Nano. There's a potential divider which I showed you, the 10k and 100k. So it basically divides 50 volts down to 5 volts. The reason I did that is to make this useful on 24 volt measurements, which we work with quite a lot in with what I do, the VSDs and stuff, and switches and proxies and sensors and so on, as well as 0 to 10 volt signals. So that gave it a useful range. And there's the 2K2s, the pull-ups from 5 volts for the data and clock line on the I2C, because you need pull-ups. Electrically, that's it. So let's have a look at the code. So starting off, analog input 0 is going to be where our voltage comes in that we're reading. Then we've got some variables, we've got sensor value, and we've got output value. Now what I'm doing is I'm averaging out the value measured to smooth it out, which is why you saw the screen when I measured 9 volts sort of count up and count down again, because I'm doing an averaging. So there's 25 readings and it takes and then displays the average. So that's what that is all about. You need these 3 libraries, y.h, adafruitgfx.h, and the ssd1306.h library to make the screen work. Screen width is 128, height is 32. Over here we do the declaration of the screen, that sort of stuff for the library. Here we initialize the screen, that's the address 03C, the I2C address. Clear the display, tell it we want white, and then write to the display by saying display and brackets. Then I'll set the text size that I want, which in this case is number 5, so we've got nice big numbers. And then the code. So here we do the counting for the averaging. We read the analog value from analog input, which is analog 0, and we add that to total. We do that 25 times. What we then do is, once the read index and number of readings has gone to 25, we exit the loop and we say read index is 0. We then come down here and we say the average is the total number of readings divided by number of readings, which is 25. The output value that I'm going to write to the screen, I map, so it's average equals 0 to 1023, which is our output value, becomes a value of 0 to 5250. It is 50 volts. It's reasonably linear and accurate. This is not a precision instrument, it's an indication instrument. If one wanted better resolution and linearity, one would use a proper A to D on this. It can be done, but for the sake of the fun we're having with it and a quick build, we've done it like this. Clear the display's previous reading. We set the cursor to horizontal 0 and vertical 0. We then print output value and we divide that by 100.0, which gives us the reading in 50 volts with 2 decimal points. And we then say display, which sends the value to the display. And then we do this again. That's what's going on in the code. Very simple, very nice. Nice little project. So, I hope that you enjoyed this little talk on this. I had fun building it. There's a little bit of 3D printing involved. This enclosure, which houses the processor, and the part that houses the display. Screw it together, wire it up, and you've got yourself a nice little project, which is quite pretty and useful. It works well. And I think that's about all I have to say about this little project at this stage. I've been looking forward to doing a review of it for quite some time, and here it is. And now you get to see it. You know about it because I published a short, but here's the proper in-depth talk about it. And that concludes this talk for today. I hope you enjoyed it. Hope it was interesting. I wish you a wonderful Sunday further and a wonderful week further, and we'll meet again for some more technical stuff. Stay well, and I'll see you around for more. Bye everybody.